So instead of just having braided streams, we can also have meandering streams, which is what most of our rivers do, meaning our rivers don't just stay in one path all the time and just follow that path indefinitely. They tend to move, they tend to meander around. This definitely happens where the gradient is low, so the land is pretty flat. So as you can see here, we've got water moving through some pretty soft material, and my river is moving around, right? That's what we call meander. So what happens is that thoweg, right, remember that's the fastest part of our river, gets modified during flood. So maybe what happens is it always follows this arrow, but maybe there's a flood, so we've got more water in there than usual. So maybe the thoweg is just shifting a little bit, and that shift is going to cause lots of erosion to happen. So that erosion is going to cause those meanders. So as you can see here in time 2, my river is cutting into, right, the rock a lot faster than, or it's cut into it more than it had before. Those cuts become more sinuous over time, or they get much more serpentine. So that cut bank erodes. The point bar, which is where my water is moving slower, is moving slow enough where we can deposit sediment. So maybe you can see how this river is just going to keep working that way, and this side is just going to keep working over in this direction. So those meanders are going to become much more pronounced. Sometimes we can get these areas where we've got this big curve, right, that's happening, and what will eventually happen is it's going to become more efficient for this river to just go straight across, right? It's going to become more efficient to just go this way. So what will happen is this meander is going to get cut off, right, by deposition. That's what we call an oxbow lake. Here you can see in this picture, there's lots and lots of oxbow lakes. You can see how much this river has meandered over time. You can see old scars even, right, out here. I like this picture. It's pretty neat. It really just shows you how much rivers move over time, and sometimes relatively a very short course of time. But of course, at the base of where our river meets the ocean is what we form a delta. We talked about this in the sedimentary chapter also. So what basically is happening is, again, my water is moving very fast in the river, and once it hits the big open part of the ocean, well, the ocean's going slow, so that river cannot maintain a high capacity, so the material just drops out, and that's what we call a delta, right, where we've got this big bundle of sediment. Of course, deltas move, as we've talked about this in class as well. So here we have the Mississippi River. The Mississippi is our sediment-dominated delta. And as you saw in that 7-minute movie that we watched, right, we build up these piles, right, and then that pile gets too big, and then we move over here and build up a pile and build up a pile, and it switches back and forth, and that's what builds up the coastline over time. But we also know that abandoned deltas degrade. This is our current Birdfoot Delta. And even though this is the active delta, because we're forcing the river to go this way, go in this direction towards Plaquemines, because that sediment is just being lost out past the continental shelf out to the abyssal plain, we're not being able to build up the coastline and build up this delta. So this delta is now sediment starved, right? So it's just going to degrade and fall apart over time. Of course, deltas can subside, meaning they're basically going to start sinking under their own weight. And of course, areas that are sediment starved are definitely going to subside at a much faster rate. And as we saw with Katrina and in this picture, right, when you've got an area that's a big basin and it's going to collect water, that's definitely never any good. If you missed that video last week, I definitely suggest taking a look at it, because it's pretty handy for understanding how southeastern Louisiana came to be.